So we are ready now to talk about migrating SQL Server workloads to an Azure SQL database. This is the first of two sections that we're going to go through on how to migrate SQL Server workloads to both Azure SQL Database and in the next section to the Azure SQL Managed Instance. There's also an optional hands-on lab that's available to you, and you can see the address here on our slide. So don't forget to check it out for more hands-on and information on migration. In this section, we will take a look at some of the options that are available for migrating to Azure SQL Database. We will also take a closer look at how to do the migration to an Azure SQL Database and then focus on service continuity for our Azure SQL Database. Azure Database Migration Guide provides step-by-step resources for migrating databases between platforms, including SQL Server to Azure SQL, and it's available at learn.microsoft.com/en-us/data-migration. The site offers up-to-date guidance, tools, and best practices tailored to various migration scenarios. A key feature is the recommendation wizard, which helps users identify the most suitable migration path and learning resources based on their environment and goals that appears at the top of this website. These guides are essential for IT professionals planning secure, efficient, and scalable database migrations. Migrating to Azure SQL Database offers a range of benefits that enhance reliability, scalability, and operational efficiency. The platform provides built-in backup and recovery, including support for long-term retention policies that allow backup to be retained for up to 10 years, eliminating the need for manual backup processes. With high availability across service tiers, general purpose, business, critical, hyperscale, Azure ensures resiliency through availability zones and a 4.9 uptime SLA. For disaster recovery, Azure SQL Database includes automated backups, geo-restore, and geo-replication, enabling data access even during regional outages or natural disasters. The platform also supports service scalability, allowing organizations to migrate, modernize, and grow their database workloads flexibly. Security is a core feature with built-in protections against infrastructure disruptions and support for regulatory compliance. Additionally, the Azure Hybrid benefit allows customers to use existing SQL Server licenses with software assurance to reduce costs when migrating to Azure. These features make Azure SQL Database a robust solution for enterprises seeking a secure, scalable, and cost-effective cloud database platform. Azure SQL Database supports two migration modes, online and offline. Online migration enables minimal or no downtime, making it ideal for production environments that require continuous availability. Offline migration, on the other hand, involves downtime during the transition and is better suited for non-critical workloads or scheduled maintenance windows. The Azure Database Migration Service, or DMS, is the recommended tool for both modes, especially for large-scale migrations, as it automates schema and data transfer and provides a streamlined experience. Several migration options are available, each with specific benefits and use cases. DMS is best for enterprise workloads needing reliability and automation. Azure Migrate helps assess and plan migrations, offering centralized tracking, transactional replication, also supports online migration with continuous data sync, and it's ideal for hybrid environments. Import-Export Wizard, on the other hand, using Backpack, is suitable for small, simple databases. Bulk Copy, or BCP, the utility, is efficient for large data transfers, but requires manual schema handling. Azure Data Factory is another option, which is ideal for complex extraction, transformation, and load, or ETL workflows, and multi-source data integration. Choosing the right method depends on your downtime tolerance, data complexity, and migration scale. For most scenarios, especially those requiring minimal disruption, online migration with DMS is the preferred approach. You can combine several Azure SQL Database migration options depending on your goals, environment, and workload complexity. For example, Azure Database Migration Service, or DMS, can be used alongside Azure Migrate for assessment and planning. Then execute the actual migration. If you need zero downtime, transactional replication can be used before or after a DMS migration to keep data in sync until cutover. Similarly, Azure Data Factory can complement DMS by handling complex ETL tasks or migrating non-relational data alongside structured databases. To successfully use Azure Database Migration Service, or DMS, it's essential to prepare your environment by ensuring key network and infrastructure settings are in place. First, enabling the TCP protocol in the SQL Server allows remote connectivity, which is crucial for DMS to access the source database. Next, configuring the Windows firewall to allow traffic to the database engine, typically by opening port 1433. This will ensure that the migration service can communicate without being blocked. If your source databases are protected by a firewall appliance, you must add specific rules to permit traffic between Azure DMS and the database, maintaining both security and accessibility. Finally, creating an Azure Virtual Network, or VNet, using the Azure Resource Manager model provides a secure and isolated environment for the migration service to operate, ensuring reliable and protected data transfer during the migration process. Make certain that you go through all of these requirements when setting up Azure DMS. Now let's look at the setup process for using the Azure Database Migration Service, or DMS, focusing on selecting the appropriate migration scenario and configuring the service instance. On the left, users choose the source and the target database types, such as migrating from SQL Server to Azure SQL Database, and select an existing DMS instance to carry out the migration. Some of the source server type options that Azure DMS supports are SQL Server, 2008 and later, MySQL, PostgreSQL, MongoDB, Oracle, and in limited scenarios, and then also RDS for SQL Server, MySQL, or Postgre. The target server type options supported are Azure SQL Database, Azure SQL Managed Instance, SQL Server on an Azure Virtual Machine, Azure Database for MySQL, Azure Database for Postgre, or Azure Cosmos DB for MongoDB workloads. Database migration service instance options include choosing from existing DMS instances or new instances, which can be configured with standard tier for offline migrations, premium tier required for online migrations, location, region, or the virtual network VNet for secure connectivity. On the right, the slide shows the form for creating a new DMS instance where users specify details like subscription, resource group, region, and the name for the service. These steps are essential for provisioning a managed migration environment that supports secure, scalable, and efficient database transfers from on-prem or other cloud sources into Azure. The Azure SQL Migration Extension is a fully managed integrated tool powered by Azure Database Migration Service, or DMS. It has been designed to simplify and streamline the migration of SQL Server databases to Azure, and it's built into the Azure Data Studio. It's really ideal for small to medium-sized databases and supports both Windows and Linux environments. The extension helps assess migration readiness, provides SKU recommendations, and guides users through the migration process using the latest DMS capabilities. The migration journey begins with 3 key steps: collecting performance data from your on-prem SQL Server, saving it locally for offline analysis, and generating tailored recommendations for the best Azure SQL target. This ensures migrations are optimized for performance, cost, and compatibility. The extension features a responsive UI, supports offline assessments without an Azure account, and is perfect for organizations modernizing legacy systems or scaling to the cloud. It also supports hybrid strategies by integrating with tools like Azure Migrate and Azure Data Factory for more complex scenarios. It supports SQL Server databases running on both Windows and Linux and does not require an Azure account to perform assessments or even to generate SKU recommendations. The Azure SQL Migration Extension in Azure Data Studio is a powerful tool designed to simplify and streamline the migration of the on-premise SQL Server database to Azure SQL. It integrates with Azure Database, Migration Service or DMS, to orchestrate data movement, assess migration readiness, and provide performance-based SKU recommendations. The interface allows users to initiate migrations, monitor progress, and assess helpful resources like tutorials and documentation. The database migration status section on the slide provides a quick overview of ongoing and completed migrations using Azure Database Migration Service, showing how many databases are in progress, completed, and total. The Migrate to Azure SQL button is the starting point for launching a new migration, guiding users through selecting source and target databases and initiating the process. Together, these features offer a streamlined, trackable, and user-friendly way to manage SQL Server migrations to Azure. You should use it because it reduces the complexity and the risk of database migrations and supports both Windows and Linux environments, and it's ideal for small to medium-sized workloads. Benefits include things like improved migration planning, reduced downtime, and a guided experience that ensures compatibility and performance optimization. Use cases range from modernizing legacy systems to scaling applications in the cloud and leveraging Azure's advanced data capabilities. What is Azure Migrate? It's a comprehensive service that simplifies the process of migrating, modernizing, and optimizing your Azure environment. It provides a centralized dashboard that supports discovery, assessment, and right-sizing of on-premises resources, including infrastructure, data, and applications. Before migration, the interface shown focuses on database migration, highlighting tools that assess SQL Server deployments, including always-on failover cluster instances and availability groups, for readiness to move to Azure SQL Database or Azure SQL VM. Azure Migrate also supports integration with third-party tools, expanding its use cases. During the discovery phase, it helps build a business case by analyzing resource utilization, estimating total cost of ownership or TCO, and identifying quick wins. Using agentless discovery and dependency analysis, it offers cost optimization insights and Azure readiness checks, making it ideal for organizations planning cloud transitions with minimal risks and maximum efficiency. Here we see the process of online migration to Azure SQL Database using transactional replication, which is the only method that allows the source database to remain online and accessible to users throughout the migration. The process begins with a snapshot of the publication's database objects and data, followed by near real-time replication of any changes to the Azure SQL target. It involves 3 key steps: creating a distribution database to manage replication metadata, setting up a publication to define which tables or views to replicate, and creating a subscription on the Azure SQL target to receive the data. This approach is ideal for minimizing downtime and maintaining business continuity during migration. Benefits include selective data replication, consistent data transfer, and suitability for high availability environments. Use cases include migrating production databases, modernizing legacy systems, and supporting your hybrid cloud strategies with minimal disruption. Here we see how to migrate a database to Azure SQL using a backpack file, which is a portable format containing both schema and data. We see the Azure portal interface where users can import a backpack file into an Azure SQL database, and includes a command line example here using the SQL package.exe to automate the process. The SQL package.exe command shown on the slide is used to import a backpack file, which again was that portable format containing both schema and data, into your Azure SQL database. It automates the process by specifying the action, which in this case is an import, the target connection string with the /TCS with server details and credentials, the source file path /SF for the backpack, and optional parameters like database edition and performance tier. The target can be used on an Azure SQL Managed Instance for migrating databases that require near full SQL Server compatibility. Also, you'll note that the SQL Server on the Azure SQL virtual machines finds it useful when you need full control over the SQL Server environment. On-premises SQL Server for restoring backups or transferring databases between local environments. So there's a lot of use cases. You could also use it for other cloud-hosted SQL Server instances, such as those running in AWS or Google, if configured properly. Now let's take a look at our knowledge check. Question 1, true or false? Azure Database Migration Service supports online migrations for Azure SQL Database. Answer, false. Question 2, which purchasing option allows you to use your SQL Server Enterprise Core license to pay for the Azure SQL Database? Answer, the vCore purchasing model. Question 3, when should transactional replication be considered during migration? Answer, when you need to minimize downtime. To review our migration to Azure SQL Database, in this section, we reviewed the benefits of migrating to the Azure SQL Database, along with some of the core migration options supported for both online and offline migrations. We took a look, too, at the requirements for migrating, how to configure the migration service, and took a look at how you can use Azure SQL migration extensions like Azure Migrate Transactional Replication and Backpack to help in the migration process to Azure SQL Database. Now let's discuss how to migrate SQL Server workloads to an Azure SQL Managed Instance. In this section, we'll dive into the most effective strategies for migrating to Azure SQL Managed Instance while exploring tools and techniques that simplify this process. We'll also cover how to keep your data in sync during the transition and highlight key considerations to ensure a smooth migration. Migrating to Azure SQL Managed Instance offers a powerful path for modernizing your SQL Server workloads while preserving compatibility and enhancing security. Migrating to Azure SQL Managed Instance supports backwards compatibility, allowing legacy applications to run seamlessly without code changes. It also delivers robust security features like encryption at rest and in transit, along with advanced threat detection, which is ideal for organizations handling sensitive data. The easy lift and shift compatibility simplifies migration using tools like Data Migration Assistant, which minimizes downtime and effort, with secure network isolation via Azure Virtual Networks or VNets. Your data remains protected from unauthorized access also. As a fully managed PaaS, Azure SQL Managed Instance offloads maintenance tasks like patching and backups, freeing teams to focus on other data tasks. Lastly, instance failover groups provide built-in high availability and disaster recovery across regions, ensuring your critical workloads stay online even during unexpected outages with automatic failover and minimal configuration. These benefits make it a compelling choice for businesses seeking scalability, reliability, and cloud efficiency without sacrificing control or compatibility. When migrating to Azure SQL Managed Instance, choosing the right migration method, online or offline, can significantly impact the success and efficiency of the migration process. Online migration methods allow continuous data replication and minimal downtime, making them ideal for production environments where availability is critical during the transition to Azure SQL Managed Instance. Offline migration options, on the other hand, are best for planned cutovers and pre-migration assessments, offering more control over timing and execution, but requiring scheduled downtime. Migrating to Azure SQL Instance has several powerful options tailored to the downtime tolerance and operational needs. Log Replay service enables near real-time replication by replaying transaction logs, making it ideal for minimizing downtime during production migrations. Azure Database Migration Service, or DMS, offers a fully managed automated migration experience that simplifies complex transitions and is well suited for large-scale enterprise environments. Azure Migrate is an offline option which provides detailed assessments and planning tools, helping teams evaluate infrastructure readiness before executing the migration. And the Managed Instance link supports near zero downtime by creating a direct connection between on-prem SQL Server and Azure, ensuring seamless data replication for mission-critical workloads. You could also use transactional replication, which keeps source and target database synchronized in real time, allowing gradual cutover or hybrid scenarios where data consistency is essential. Finally, native backup and restore allows you to take a full backup of your on-prem SQL Server and restore it directly to your Azure SQL Managed Instance. This offers a straightforward offline migration path that is especially useful for smaller databases or environments where downtime is acceptable. The Log Replay Service, or LRS, is a specialized migration tool that enables custom, low downtime migrations from on-premises SQL Server to Azure SQL Managed Instance using log shipping technology. It is particularly beneficial when Azure Database Migration Service, or DMS, isn't viable, such as in an environment with strict control requirements, limited access to backups, or restricted networking capabilities. The migration process follows three key steps. First, database backups are copied to the Azure Blob storage. Next, it establishes the foundation for migration during that process. The LRS service is then started in the cloud, enabling continuous synchronization of transaction logs to keep the target instance up to date. And finally, once data is fully synced, a cutover to the cloud is performed, completing the migration with minimal downtime. LRS can be orchestrated using PowerShell, CLI, or your favorite REST API, making it ideal for organizations that need granular control over the migration timeline and process. The Azure SQL Managed Instance link offers a true online migration path by enabling continuous data replication from on-prem SQL into our Azure SQL Managed Instance with minimal downtime. This makes it ideal for organizations seeking high availability and a phased approach to the cloud adoption, allowing workloads to run partially in Azure while still benefiting from cloud scalability and resilience. The link supports one-way replication from SQL Server 2016 and 2019, where manual failover to Azure is possible during a disaster, though fallback isn't supported. For SQL Server 2022, it adds full disaster recovery capabilities, including seamless failover and failback between the environments. Multiple links can be configured to replicate several databases from a single SQL Server instance to one or more managed instance, or even replicate the same database to multiple targets. This flexibility is especially useful in complex environments where installing migration tools like DMS isn't feasible or where the network constraints limit direct connectivity. Overall, the link feature empowers organizations to maintain business continuity, reduce migration risk, and modernize their infrastructure with greater control and confidence. Here we see the backup and restore migration to Azure SQL Managed Instance, which allows quick and straightforward migration of databases using the .bak files stored in the Azure Blob Storage location. This method supports SQL Server running on an Azure VM and is particularly useful for asynchronous migrations where downtime can be scheduled. The process begins by backing up the SQL Server database to a URL that points to the Azure storage account, as shown here in the backup database T-SQL syntax that is pointing to the My Storage account. And then not shown here, you will need to have a shared access signature to securely access this storage. Next, the actual migration is performed using the restore database command, which restores the database directly onto the managed instance. The diagram reinforces this workflow visually, showing the flow from on-premises or Azure-hosted SQL Server to Azure Storage, and finally to the managed instance. The T-SQL syntax examples here, backup database to URL, and restore database from URL, demonstrate how simple and direct the method is, making it an efficient choice for migrations that don't require continuous replication or complex orchestration. Azure SQL Managed Instance offers a variety of methods for moving data to and from the cloud, each tailored to different migration needs and operational scenarios. Backup and restore uses the .bak files stored in the Azure Blob Storage, allowing for asynchronous migrations with scheduled downtime. This is ideal for very large databases, and it's supported by both on-prem SQL Server and the Azure Virtual Machine. Backpack files package schema and data into a single archive, simplifying the transfer of smaller databases between environments. The bulk copy program, or BCP, is a command line utility that efficiently handles large-scale data transfers, making it perfect for high-performance scenarios. Detach and attach provides control over physical database files, the MDF and LDF, and it's useful when direct connectivity is limited or manual file handling is preferred. Azure Data Factory and SQL Server Integration Services, or SSIS, offer robust ETL capabilities for complex workflows involving data transformation and integration from multiple sources. Additionally, transactional replication enables real-time synchronization of data between on-prem SQL and the Azure SQL Managed Instance. This allows for gradual cutover and hybrid scenarios where both environments remain active during migration. Now it's time for our knowledge check. Question 1. Can transactional replication be configured from the Azure portal? Answer: no. Question 2. What is the primary use case for the log replay service for Azure SQL Managed Instance? Answer: to migrate databases from on-premises SQL Server or virtual machines to Azure SQL Managed Instance with minimal downtime. Question 3. What is the purpose of using SQL Managed Instance link feature during migration? Answer: to minimize downtime during migration by extending an on-premise database into the cloud. For more information on what is Azure SQL Managed Instance or what is Azure SQL Database, or to see the Azure Database migration guides, please see the URLs here. To review our section here on migrating to Azure SQL Managed Instance, we reviewed the benefits of migrating to Azure SQL Managed Instance along with some of the core migration options supported for both online and offline migrations. We then took a deeper look into the log replay service, or RLS. We looked at the Azure SQL Managed Instance link feature, and we did a backup and restore. We also lastly talked about other options to move data to and from the SQL Managed Instance like Backpack, Bulk Copy, Program, also working with Detach and Attach. And we also mentioned the Azure Data Factory and more. In this section, we explored how to manually set up and configure Azure resources, gaining deeper insight into the underlying systems and processes that support cloud-based solutions. We also learned how to evaluate business and technical requirements to recommend the most suitable Azure SQL offering. Finally, we explained the various tools and features available for migrating databases to Azure SQL Database and the Azure SQL Managed Instance, empowering us to choose the right strategy for our scenario. As we just saw, by mastering both PaaS deployment and migration strategies with Azure SQL, you're not just modernizing infrastructure, you're enabling innovation. Whether you're provisioning scalable solutions or transitioning legacy systems to managed instances, you now have the insights to guide your team with confidence. So what's the next step? Put these tools into action and unlock the full potential of cloud-powered data management. Thank you for viewing this session, and I look forward to seeing you in the next.